So let's look at identifying linear and exponential functions from a table. We have already looked at tables of linear functions, and here's an example, right? I could have x's that are, say, 0, 1, 2, 3, 4, y's that are 15, 13.8, 12.6, 11.4, 10.2. We actually could determine that this is a linear function because the slope is constant for the entire function. And I actually went through and did the process of doing change in y over change in x between 0 and 1, 1 and 2, 2 and 3, and then 2 and 4. Actually, 3 and 4 ended up being. And every time I do the slope, I end up getting negative 1.2. So now if I move forward and I take a look at the table of an exponential function, here's my example. Again, I used x's that are 0, 1, 2, 3, and 4. And then I did 80, 96, 115.2, 138.24, and 165.888. To determine if a table is modeled by an exponential function, what we look at here is the ratio of consecutive y values. Now, it is critical that when I look at the input side of things, that there's an equal distance between those inputs. So 0 to 1, 1 to 2, 2 to 3, 3 to 4, that I can't compare 0 to 1 with 1 to 3 without doing a little bit of other math. So this process only works if there's an equivalent distance between the inputs. What I'm going to do is I'm going to do the ratio of the two consecutive y values. And I'm always going to take the later divided by the earlier. And the reason that I'm going to do that is in many of these cases, that's going to give rise to the b that we've used in our formula in the previous section. So if I did 96 divided by 80, I get 1.2. If I want 115.2 divided by 96, I get 1.2. If I did 138.24, I get divided by 115.2, I get 1.2. If I do 165.888 divided by 138.24, I get 1.2. So again, notice I get the same value every time. Just a couple of quick notes. We use the later y divided by the earlier y. Again, that's because that's going to help us with our b later on. And again, remember, this method of checking will only occur if the input values have a common increment, like our 1, 2, 3. Since that ratio, though, was always 1.2, that indicates to us we have an exponential function. So if we have equivalent slopes, we have a linear function. If we have equivalent ratios, we will have an exponential function.